Hello, viewers. Welcome to the class for today. Today, we want to add these fractions together and also to simplify the other group of fractions. My student will join the class right now. You can subscribe to this channel. Thank you. How are you today? Um, can you hear me? I cannot hear you. Korea, can you hear me? Can you hear me? I can't hear you at all. Check your audio, or you can log out and join again. Now let's try again now to see whether it's going to be able to hear me. Can you hear me now?
Yeah,
How are you?
good.
Okay, now you're welcome to class for today. You remember I gave you an assignment. Did you do it?
The title.
Which was this one. Well, we're going to do it together quickly. Let me see what we have here. This one is 8 over 9. That's number one. Let's see, number one. 8 over 9 plus 5 over 8 plus 10 over 11, okay?
Mm,
So looking at all these ones, there is nothing common to all of them. So the LCM is as good as multiplying the three numbers, okay? Is that clear?
mm, yes.
So 9 times 8 is 72. Then 72 multiplied by 11. That's going to be the LCM. And that's 792. So I can say how many 9 goes in 792? That's 88. Then 88 times 8, that's 704. Then we have how many 8 goes in 792? That's 99 times 5, that's 495, okay?
Mm,
Then let me join a line here. Then the other one, how many 11 goes in 792? That'll be 72, okay? All right. Now 72 times 10, that's 720, okay?
eh,
Then you have, let's see, we have to add all these numbers together. So 704 plus 495 plus 720. That is 1919 over 720. So we divide by 720. How many 720 can we see there? That's 2, whole number. So we can say 720 times 2 is 1440. So take it away from 1919. You have 479 over 720. So you're going to write down this example. Then you do the remaining two as classwork when you're through, which is number 1. So write down the examples quickly and do the classwork, okay?
8.
We have 12 over 15 plus 9 over 12 plus 7 over 10. Then the second one, 3 over 5, 5 over 7, and 10 over 12. So write down the example. When you're through, I will display this classwork for you to write. All right, I'm going to continue shortly. Have you finished the work?
No.
Okay, what will happen is that I will send it as part of your homework, but I'm going to be doing a report to your mom that you've not been doing your homework. Should I do that?
No.
So are you
No.
promising? Are you promising you're going to do it?
Yes.
So now look at this second one. I'm going to give you this one also, but let me explain briefly. Are you there?
Yes.
Okay. What's the first question?
55 over 10.
55 over 10. What is the instruction?
Uh,
What's the instruction?
what is this? What is an instruction?
What is the information at the top that you're supposed to follow?
Reduce improper fractions into lowest
Into
terms.
lowest terms. So what number can divide 10 and 55? Tell me. It's 5 that can divide them. 5 in 55 is
5.
11, and 5 in 10 is 2. So you can change it to how many 2 goes in 11? That's 5. Remainder 1 over 2. Is that clear?
Mm-hmm.
Number 2, what number can divide both of them is also 5. 5 in this one, that's 7. Okay. 5 here, that's 4. Then you can change it to what? 1 whole number 3 over 4. You know, we've done conversion before, right?
Yes.
So I'm not going to do more than 4. The third one, 5 here, 7, 5 here, 3, right? So how many 3 goes in 7? That's 2 whole number 1 over 3, okay? And the fourth one,
Yes. 2.
what number would divide 68
Okay.
and 24? What number? Let's use 4. 4 in
Uh,
4 in 6, that's 1. 4 in 28, that's 7. 4 in 24, that's 6. So that's 17 over 6.
mm.
How many 6 goes in 17? That's 2, which is 12. Remainder 5 over 6. Okay. I'm going to send
Uh,
everything over so you make sure you complete the 2 assignments, okay?
yeah.
Bye for now.
I know.
All right, viewers, thanks so much for watching this. You can subscribe to this channel for updates on our future videos. Goodbye for now. Countable and uncountable objects.
Today, Mr. Achibola.
How are you today?
I'm good.
All right, you're welcome to class for today. Um, we're dealing with countable and uncountable objects. The first object is cloud, and you cannot count cloud. That one has been done for us. And the next one is fish. Fish. So, can we count fish?
Probably if we have them in the bag, it depends.
Hmm, that's true. So we can count fish. So we can say this is count. We can say countable. So then, what about milk? Non-count. It can only be measured, right?
Yeah.
So say non-count. countable, or simply put, uncountable. So the next one is it actually
Stars.
is it actually star
I think so.
or cookies?
I'm not sure. A cookies will look brown.
Yeah, it looks brown or black or brown or something, and it has some, if you say stars, uncountable, but the main thing is that the stars are numerous, right? You understand?
Yeah.
So let's see, stars countable. The main thing, you can count if you see three stars, you know three stars, right? And if you see one
Yeah.
star, though there are many, but you don't just suddenly group them together, so you can still count. So you can still say stars are countable nouns, okay?
Okay.
You can say one star or three stars. You can still refer to them individually. So, but then if we are not going for stars, we are saying maybe you are going for
But
cookies.
actually, it depends how many stars there are. Imagine you got like a whole sky is filled with
Even if
stars.
it's a galaxy of stars, you can still refer to an individual star, right?
Yeah.
But like milk, can you refer to an individual milk? No. Or individual sand? No. You understand? Okay, so that is countable for this one. Then the next one, we talk about books. Well, that if they are books, yeah, books are countable, okay?
Yeah, but what's that spelled beside it?
That's why I'm just even trying to see whether it's a bowl that contains something or. But if we go for books, we'll say countable, okay?
Okay.
Let's see. So we say countable. So pumpkins are countable. What's the last one? The envelopes. You can count them. Countable. So we can say books, books, envelopes. Then this is hat, which is also like a cap, countable. Then doorknob, it's also countable. Then water, uncountable. Candle,
Is the candle melted?
yeah, that if it melts, you can now talk about uncountable. But as it is solid, it's countable.
Okay.
Then soup is uncountable. Okay, tablet is countable. And the next one is road, non-countable.
Yeah, because the road keeps going on and on.
Yeah. So out of 13, you get 12. That's a very good job. Okay, hold on. I'll give you something to try shortly, okay?
I have homework,
Oh, you can
and
send it.
they just started grading my homework.
Okay, send it to me.
Okay.
All right. Continue shortly. So, can you hear me now?
Yes.
For this one, we have right P for prime and C for composite next to each number. You know, composite number that have factors that you can multiply. Okay,
Yeah.
that you can multiply to get a number. For example, 10, you can get 10 by saying 2 times 5, apart from 1 times 10. So it's a composite.
And then 2 times 5. Well, wait. Oh,
Yeah,
I did it. Okay, wait.
and I said 2 times 5, but also 1 times 10. 1 times 10 does not really count, but it's 2 times 5 that counts. And for 11, because it's only 1 times 11 and nothing more, that makes it a prime number. Then for 12, it has a lot of factors, so it's a composite number. 13 is a prime number because only 1 and 13. 14 is a composite number. 15 is also a composite number because 5 and 3 can multiply and give us 15. Then 16 is a composite number, but 17 is a prime number. Exactly.
Yeah.
So circle the prime numbers here. Okay. The prime numbers are 37, 41, and 43. How can you tell if a number is composite?
I
Then
think I
explain
can tell.
why
I,
11 is prime. Yes.
I think I can tell that. I can tell because the other numbers can be times to get the numbers. The
Yeah. So
the number.
part 3, no. It says if you look at a number, how can you tell if it's a composite number? So you have to consider the factors, right?
Yeah.
So you find all of its factors. If it has more than two factors, it's a composite number. So if a number has
Has
more
more than one.
more than two factors,
Two.
two factors, then it is composite number. For example, 10 has all the factors 1, 2, 5, and 10. So it's a composite number. The the second part of that, part 3, that's part 3b. So explain why 11 is a prime number. 11 is a prime number because because nothing, I mean, it has only two factors because
Because Wait, how does it have only two factors?
Hold on. It has only two
Wait,
factors.
what else is the factors? What's
So
the other factor?
one factors of 11 are 1 and 11. Okay?
Wait, okay.
So any number that doesn't have more than 1 and itself as a factor, then it's a prime number. But anyone that has more than 1 and itself, then it's a composite number. Okay? When you finish this, let me know.
Okay.
Alright, we're gonna continue shortly. So the first one is syrup. You can only measure syrup, so it is non-count. Cone. You can count how many cones are there. So
Ice cream cone?
then cheese. You can only cut out cheese. You cannot count cheese, so it's non-count.
That was what I was talking about.
So tea is also non-count. Flour, you can count how many flowers are there. Dresses, you can count how many dresses are there. Joy is non-count and it's also a noun. Desk, you can count how many desks are there. Mustard, mustard, so no, you can count it, so it's non-count. Then shoe, you can count the pairs of shoes that are there. So thought, so you can count that. Then we have anger, non-count. Seafood is also non-count because food itself is non-count. So then we have butter. Butter is non-count. You can only measure hard butter.
What do you mean by butter? You mean the melted butter or like a lot of butter?
Just butter. And when it is, you can count it, but it could be in lumps or something or containers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 14. Still a good job. Take note of your correction before we round up.
Okay.
Alright, viewers, thanks so much for watching. You can subscribe to this channel. Goodbye.